Okay, welcome back. Now we're going to talk about average and instantaneous rate of change. Remember, ROC stands for rate of change. Okay, so recall that average rate of change is this quotient difference, which is f at a plus h minus f at a over h. And we notice that this appears here in the limit for when we're finding a derivative. We're going to talk about that in a second. So the average velocity of a moving object over an interval of time is the change in distance divided by the change in time. So we've seen this formula in the past before, right? We have velocity is equal to distance over time. This is the same thing you see if you drive or if your parents drive. If you ever notice that we have, for example, 60 kilometers per hour is the limit, right? This would be the speed in our case. Right? So the speed is 60 kilometers per hour. Now, velocity is actually how does speed change in each moment in time. So say, for example, you're driving on the highway, right? You're about to merge into the highway. Everybody's driving. And you're starting at 20 kilometers per hour. You have to be slow. And you speed up up until 60 kilometers per hour. And then you speed up until 100 kilometers per hour, which you're going to stay at for the duration of the drive on the highway. So the average velocity, right, is actually going to be the change that you made in the speed that you're going at, basically. So 20 kilometers per hour is the instantaneous speed. That's the speed you're driving at. 60 kilometers per hour is also the same speed. Velocity is the change in this speed through time. So in 3 minutes, you manage to jump from 20 kilometers to 60 kilometers, right? The change here is 40 kilometers for those 3 minutes, and then you do some calculation. So velocity talks about this change in speed and the distance covered in time, okay? So also, next one is recall instantaneous rate of change of f at a at a particular point in time, right? A is something in the domain of f, is f prime at a. So is the derivative of f at a, which is also just the limit as h approaches 0. So in the same difference quotient that we had here, h is going to be the distance, right, between this new point in time to the original point in time a, right? So if a exists here and this is a plus h, this means that the change here is h. So instantaneous rate of change says as these 2 points get closer and closer together, because h becomes smaller and smaller and smaller, it approaches 0, right? So originally it'd say h is 30, and then it approaches 0. What happens to the function as these 2 points essentially just become one singular point in time and they meet? Okay? Little side comment as well for these next few problems that we're going to be covering. The position of a function is usually given to us as f at x, usually, okay? Now, the velocity of a function is going to be the derivative of that position function, okay? And the acceleration is going to be the velocity's derivative, or just the second derivative of the position function.